Well, hello, mathematicians. Welcome back. Today we're looking at guided practice problem number 4 in chapter 4, lesson 3 for course 1 of Math and Focus. And we're looking at what happens when you have two different ratios with different terms that are somehow related. How do you reconcile those ratios and use them to solve problems? So at Stacy's middle school, students either ride bikes to school, walk, or take the bus. And the ratio of the number of students who ride bikes to the number of students who walk is 3 to 4. And the ratio of the number of students who walk to the number who take a bus is 12 to 7. And there are 560 students in all. So let's just keep track of our information in a logical way. Here we have, we have the students who ride bikes to the number who walk, and that ratio is 3 to 4. And then we have the students who walk to the ones who take the bus, and that ratio is 12 to 7. Now, I want you to take a look at this center set of values here, the students who walk. Did the number of students who walk just magically increase 3 times? Did it triple? And the answer, of course, is no, it did not triple. The students who walked remain the same, but the relationship between the other quantities is a different relationship. So the students who walk to the students who ride bikes, it has a different mathematical relationship than the students who walk to the ones who take the bus. And therefore, these numbers are different. But you see, they're related. And we're going to use that relationship to help us in solving this problem. So here is our first bar model. And you see that the ratio of 4 to 3 is, or 3 to 4 rather, is represented quite well. We are able to use this initial relationship to figure out how to relate all of the bars the same way, right? So here is the first ratio. Ride bike to walk is 3 to 4, right? And we need to make an equivalent ratio that is going to help us. And to do so, we're going to look at these two numbers here, 4 and 12. So if you multiply 4 by 3, you get 12. And you can do the same thing with the walkers. 3 times 3 is 9. So we can have a new relationship of 9 to 12 here. And we could get that by subdividing the existing bars we have, right? So that the original 3 units that we had here, and I'm marking the original lines, become now 9 units. You see that? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 3 plus 3 plus 3 gives us now, instead of 3 units, we got 9. And we can do the same thing with walking. Here are the original bars. I'm going to make them in dark black. And if we subdivide each of these into 3 groups, right, we have 3 times 4, which is 12, which is the number we wanted because of our ratio here, 12 to 7 for walkers to the ones who take the bus. That ratio being 12 to 7 right here. Okay, so our final blank on this page asks us to give a ratio for those who ride the bike. So the riders to the walkers to the bussers, right, is, well, we know walk to bus is 12 to 7. And now we've rewritten this ratio, right, the bikers, using the same factor of 3 to make an equivalent ratio so that our new ratio involves 3 terms, 9 to 12 to 7, all right? And that comprises 560 students in all. And have we answered our question? Not really, because our question's still up here. Find the number of students who ride bikes to school. Can you do it now at this point? If all of the units are the same, you should be able to figure it out, right? And each unit, do we know what each unit is? We don't yet. That's what we have to do next. So let's pick up where the last page left off. I didn't have enough room to put everything at once. So ride bikes, to walk, to take the bus was 9 to 12 to 7, right? And we have a total number of units then. If we add 9 plus 12, we get 21, plus 7, that's 28 units altogether. Okay, that's 9 plus 12 plus 7 gives us 28 units. So 28 units are 560 students, right? There are 28 little boxes over here in these bar models, and they represent 560 students. So in order to find one unit, we have to divide 560 by 28. And as we do that, we see that there are 20 students for each unit. All right. So every one of these is 20. Well, there are 9 units of bikers. And 9 times 20, you know that 9 times 2 is 18. So 9 times 2 tens is going to be 18 tens, which is 180. So we have 180 people riding the bike to school. So the next thing says, find the number of students who walk. Well, how many units are there for walkers? Oops. As you can see here, we have 4 groups of 3, which is 12 units of walkers. And so we're going to multiply those 12 units times 20 students in each and get 240. So the number of students who walk is 240. And let's go ahead and put the number of students who bike up here too. That was one of the answers we were asked for. 240 is another. And we'll just put an arrow here, 240, so we can keep it straight. That one of mine looks like a 2, so let's make sure it's 180. All right, so then the next one is to find the number of students who take the bus. And so for the busing students, well, let's see if we can we see that there are 7 of those units. Oh, we were given that actually originally. So 7 times 20 is 140 students. So 140 students take the bus. And we're done. However, we always need to check back and make sure that our work is correct. So we have 180 plus 240 plus 140, all right? 4 and 4 tens is 8 tens plus another 8 tens is 160. And we have 5 100s there. So 560, that checks back to what we were originally given. So we know our work is correct. And that's all I've got for you. See you again soon.